Hello, welcome to Business Statistics. In this lecture, I will discuss about empirical rule. So, empirical rule is applied to a data set which is normal distribution. We can say normal distribution is a bell-shaped curve or a symmetrical curve. So, empirical rule is if we have a data set which looks normal or bell shaped or symmetrical, then 68% of the data is within one standard deviation of the mean. And then 95% of the data will be within two standard deviation of the mean. And 99.7% of the data will be within three standard deviations. Of the mean. So you can remember this by saying 68, 95, 99.7. So we will look how this looks on a normal distribution. So if we have a normal distribution or a symmetrical curve, so this will be our mean. So this is normal distribution. So the center would be mean, and then we have one standard deviation which is mu plus 1 sigma, and then this is mu minus 1 sigma. So that's one standard deviation. So this area in the normal distribution is 68%. So what it is saying is 68% of the data will be within one standard deviation of the mean. And then if we have two standard deviations, so this is mu plus 2 sigma and this is mu minus 2 sigma. So this entire data is 95%. So this whole thing is 95%. So that is two standard deviations from the mean. And then we have mu minus 3 sigma and mu plus 3 sigma. So this whole thing, whole area covers 99.7% of the data. So a normal distribution goes from negative, so this would be negative infinity to positive infinity. So this entire area from negative infinity to positive infinity should be 100%. So this is what a normal distribution says. So we will try to address normal distribution by taking the empirical rule by taking a simple example. So if we have a statistics class and I measure the weight of all the students in a statistics class and I get an average, which is mu, weight of the entire class as 180 pounds, and the standard deviation of the class is 10 pounds. So our normal distribution, so as we discussed, so we have a normal distribution which looks bell-shaped or symmetrical, and the center of the distribution is our mean mu. So in this case our mu is 180, so the center would be 180. And then we said this is one standard deviation, positive one. So when I say mu plus 1 sigma, so I'm doing 180 plus 10, that is 190. So that would be positive side of 1 sigma, and then negative 1 sigma would be mu minus 1 sigma. So 180 minus 10 would give us 170. So this is again 68%. So what we are saying by this definition is, if we take the class, the number of students between 170 and 190 weight would be 68%. And then we have mu plus 2 sigma. So this will be like 180 plus 2 times 10, or if we add 190 plus 10, that's 200. So mu minus 2 sigma on the other side. So this would be 160. So 180 minus 2 times 10 would give us 160. So this whole area will be 95%. Again, what we are trying to say is around 95% of the students will have a weight between 160 and 200. So the next is 3 sigma. So that is mu plus 3 sigma. So this will be 210. And then mu. So if this is extended like this, so I will use the same color. So this is mu minus 3 sigma would be 150. So this whole area is 99.7%. So again, what we are saying is around 99.7% of the students will lie between 150 and 210 pounds of weight. So that is a kind of an example which we can use and do our analysis. So we will try to do some problems in this for this example. So we have a class whose mean is 180, and then whose standard deviation is 10 pounds. So this is also pounds. So if someone asks us what percentage So percentage, this is E of students have weight below 170 pounds. So if we see, we have a normal distribution. The mean is 180. So we are looking for weight below 170. So this would be 170. So we are looking for what percentage, how much is this area. So we know this whole thing from negative infinity to positive infinity. So this is negative infinity to positive infinity is 100%. And then that means half of it, this whole area would be 50%. So this is 170 is -1 standard deviation. So if we see, we have +1 standard deviation. So this whole area is 68%. That means this half would be 34%. So now if you see, I wanted this area. So if you see, if I do 50%, which is this area, this half of it, minus 34%, this would be 16%. So the other way is this plus this, 16% plus 34 should give us 50%. So that means the percentage of students below 170 pounds is 16%. So this is, the answer is 16%. So we can solve another problem on this. Percentage. So we are looking for what is the percentage of students above 160 pounds. So again our mean is 180 pounds. Our standard deviation is 10 pounds. So if we draw a normal distribution curve, the center is again mean mu, which is 180. So this is our mu, and then we are looking for the area above 160 pounds. So that is percentage of students above 160. So 160 would lie somewhere here. So this is one standard deviation, which is 170, and this is two standard deviations, 160. So this is mu minus 2 sigma. So we are looking for this area. So we are interested in knowing what is that percentage. So to calculate that, this is negative mu minus 2 sigma. If I know mu plus 2 sigma, so let me change the color. So this is mu minus 2 sigma. So mu plus 2 sigma is somewhere here. So this would be, suppose this is 1 sigma, so this should be 190. This should be 200. So if you see this whole area 160 to 200 is 95%. That means this area plus this area should be 5%. So because the curve is symmetrical, we can divide the 5% into 2 halves, which is 2.5%, and this would be 2.5%. So now if you see, we are looking for area above 160, which is this whole area. So that way we can obtain by doing 95%, which is until this point, and then we add this another 2.5%. that will give us the weight of students above 160. So when we add them, we will get, this is 2.5, 97.5%. So the percent of students above 160 pounds would be 97.5%. So we can solve another problem on this. Now we are interested in percentage of students below 160 pounds and above 210 pounds. So again we will use a normal distribution curve. So if this is 180, so one standard deviation on the positive side would be 190, on the negative side would be 170, and then on the positive side it would be two standard deviations would be 200. On the negative side, two standard deviation would be 160. So we wanted below 160, so we are looking for this area on the left side, and then we have above 210, so we have to look for three standard deviations 210. So we are looking for this area. So this is mu, this is mu plus 1 sigma, this is mu plus 2 sigma, this is mu plus 3 sigma, and then this is mu minus 1 sigma, and this is mu minus 2 sigma. So we are looking for this area plus this area. That's what our question is asking us. So if you see, this is 160. So if you see this mu minus 2 sigma to mu plus 2 sigma is 95%. So the remaining area, which is this plus this, should be 5%, this whole area. So this would be 2.5% and this would be 2.5%. So we got this side 2.5%. Now if we look at 210, so this is where we wanted this whole area above it. So if we have, this is mu plus 3 sigma. Now if we have mu minus 3 sigma, which is 150, so this area from here to here would be 99.7%. So the remaining area, which is maybe this and this, would be 0.3%. So half of it would be 0.15%. So this will be 0.15, this will be 0.15. So if you see, we are interested in this whole area, which was 2.5%, and this after 3 standard deviation. So when we add 2.5% with 0.15%, that will give us the percentage of students below 160 and above 210. So we need to add 2.5 plus 0.15, that is going to give us 2.65%. So that's how we solve these problems. So we will solve one more final problem and see if we can understand in more detail. So now I wanted to calculate percentage of students above 170 pounds and below 200 pounds. So again we can draw our normal distribution curve, and then this is our mean, which is 180. So this is mu, and then this would be 170 mu minus 1 sigma, and this would be 190 mu plus 1 sigma. This would be 200. So this is mu plus 2 sigma. So we are interested in this whole area. How much is this area, or what percentage of the students lie in this area? So if you see, this whole thing is 84%, no, 68%. So this will be 34%. And then, so we got this whole area at this time, which is 34%. Now we need this whole area. What is this? So to calculate that whole area, if you see, this is mu plus 2 sigma, then we can have mu minus 2 sigma, which is 160. So this whole area is 95%. So if you bring in this, half of it would be this whole area, this whole area, so which is 47.5. So this area is 47.5. So the entire area would be sum of this and this, which is 34% plus 47.5, which is 81.5. So the percentage of the students who lie between 170 and 200 are 81.5%. So this concludes our lecture on empirical rule. Thank you.